So in the last chapter we studied about final variables and we learnt about a story about how conventions are important. So in this chapter we will study about numeric data types. So here basically there are 8 primitive data types are available in Java. Okay, out of which 6 are numeric data types. Okay, 6 are numeric data type. One is character data type and the last one is boolean data type, is not string data type. You might have thought that when I say last one you thought about string, probably some of you. So 6 are numeric, one is character data type and the last one is boolean data type. So today in this lesson we'll study about the 6 numeric data types available in Java. Okay, so that is byte, short, int, long, then float and double. Okay, so what's the difference? See, when I asked you to write and program to add two numbers in the assignments, okay, you might have created two variables where you might have stored the value like 10, 20. So basically to store very, let's say, small amount of data, we are wasting this much of space. Get it? So why? Because you used int there. You are storing 1020. Further, the variable names you might have used int. So if you are storing the value like 1020, we can simply go for byte. So how do you know what number will fit in what type of data type? I have created an image here. Just have a look at it. Byte size in byte is 1 byte, whose range varies from either you can say 1 byte or we can say 8 bit. Okay, in the notes I have given a different image altogether. For the explanation purpose I have taken this one. Just understand this 8 bit. So short is double of this, either 2 bytes or you can say 16 bit. Now the range, how did we got this range here? Simple. So if it is 8 bit, so this is 8 bit, right? The byte size is 8 bit. So you can reduce the formula as minus 2 to the power of 7. So that is 8 minus 1 you have to take. If it's 8 bit, 8 minus 1. Short is 16 bit. So minus 2 to the power of 15. Int is 32 bit. Long is 64 bit. Okay, I'll come to float later. So we can say byte minus 2 to the power of, the range we can verify as minus 2 to the power of 7 to 2 to the power of 7 minus 1. So that is minus 128 plus 127. Same if you go for short. Okay, so the range will be minus 2 to the power of 15 to 2 to the power of 7 and so on for int and long. So if you are storing 10 and 20 kind of value, just stick to byte. Now for float, okay, for the float, this is what exactly is followed. The float follows 32 bit IEEE 754 standard. Okay, where shall I add it? So let me add it here simply. Okay, I hope it is visible to you. So for the floating point it's 32 bits. Same way double is 64 bit. Double is 64 bit. 64 bit. IEEE 754 standard is used. Same as this. Okay. So what did you understood by this? Okay. So I am talking only about the numeric data types now. I am not talking about character data type yet. Okay. So now this is a one division. This is for storing the integer values. So now we already got the range and I do not expect you to remember the numbers like this. So that's the reason I gave a shortcut here. How to deduce it. So have you noticed here every type, higher type is double of previous type, 8 bit, 16 bit, 32 bit and 64 bit. So the range also varies like that. Okay, I hope this clarifies. What is this default 0? That you will understand in the arrays class, not now. For now, please just ignore this. Okay. Now same way, to represent the floating point numbers, there is a float. There's a data type called float and there's a data type called double. So float is 32-bit IEEE 754 standard. So what is IEEE 754 standard? You don't need to scratch your head so much, just theoretical understand that there is a standard called IEEE 754 standard. IEEE is basically Institute for Electronical and Engineering. So it's a community who makes the standards, and technically speaking, to represent the floating point number there will be an hardware level dependency. So Java programs which are running in any system, their system, the CPU should support IEEE 754 standards to represent the floating point numbers, and the double is double of float. So this is a simple introduction to numeric data types. Okay, if you simply say 10 in Java, okay, this is called as literals. You can say there's a chapter called literals. I did specify the same thing in the notes. If you say 10, 10 is considered as of type int. Get the point? Same way, if you say 10.1, it is considered of type double, is not of type float. Understand this. So you cannot simply say float f equal to 10.1. You will understand, we'll get the same example in type conversion. If you want to set a number of type float, then you have to suffix with f. Make sense? Okay, so that is literals. This is an integer literal. This is an 10.1 or 10.1 f is a floating point numbers. They are floating point literals. But 10.1 is of type double. When you suffix with f, it is of type float. Okay, remember this in the future lessons in the type conversion. You need to have a knowledge of this. See you in the next video.